Welcome to The Explainer. Today, we're pulling back the curtain on how modern websites keep your account safe and sound. We're going to look at that elegant digital handshake that happens every single time you click a link, making sure the site always knows it's really you. All right, let's just dive right in with a question that we've all experienced, even if we haven't really thought about it. You log into your email, you click on a message, and poof, it opens. You didn't have to type your password again. How does the website keep trusting you from one click to the next? Well, the first piece of this puzzle is a really powerful idea in web development called middleware. You can think of it as the first line of defense, a guardian standing at the gates of a website's private areas. So, what on earth does that actually mean? It's pretty simple, actually. Before your request to see a protected page, say your account dashboard, even gets to that page, this middleware code jumps in the way. It basically intercepts the request, so it can take a quick look and decide, should this be allowed through, or should we send it somewhere else? You know, this analogy is just perfect. The middleware is like a bouncer. It's not worried about what music is playing inside or who's on the dance floor. Its one and only job is to stand at the door and check everyone's ID before they're allowed to step inside. It's a dedicated gatekeeper for your app. And its job is super focused. First, it stops every single request trying to get to a protected area. Second, it checks that request for some kind of credential, an access pass. And third, based on whether that pass is legit or not, it either opens the door or it points you right back to the login page. Simple, right? But incredibly effective. Okay, so if our middleware is the bouncer, what kind of access pass is it looking for? It's not a driver's license, of course. It's a special kind of digital key. And that brings us to the other hero of our story, the JSON Web Token, or JWT for short. See, when you first log in with your username and password, the server checks them, and if they're correct, it generates this unique token just for you. Your browser then holds on to that token and flashes it at the gatekeeper with every single request you make. And this thing is more than just a random string of text. It's what we call cryptographically signed. That means our bouncer, the middleware, can instantly verify two really important things. One, that the key was actually issued by the right server, and two, that nobody has messed with it. It's a secure, self-contained proof of who you are. If you were to look at a JWT, you'd see it's made of three parts, all separated by dots. First step is the header, which just says, hey, this is a JWT, and here's how I made it. Then comes the payload. This part carries useful but not so secret info about you, like your user ID, or maybe that you're an admin. And I can't stress this enough, you never, ever put a password in here. And finally, you have the signature. That's the secret sauce, the part that proves the token is legit. All right, let's put this all together. Let's see how our gatekeeper and this magic key do their dance in the real world, starting from the second you hit that login button. So here's how the whole thing plays out. You log in, the server checks your password. If it's a match, boom, it creates your special JWT. That token gets sent back to your browser and tucked away in a special HTTP-only cookie. Now this part is super important. HTTP only means that no rogue JavaScript on the page can get its hands on your key, which helps prevent theft. So then, when you try to visit your profile page, the middleware steps in, finds that JWT in the cookie, and instantly verifies it. And from there, the outcome is clean and immediate. If the key is valid, you're in. You get to see the page you asked for. If the key is missing, or it's expired, or it's just plain wrong, you're sent right back to the login screen. No valid key, no entry. So why do we go through all this trouble? Why is this specific pattern so important for modern web security? Well, it's not just about letting people in. It's about doing it in a way that's both safe and incredibly efficient. And you have to know, not all tokens are created equal. A secure token has a short, defined expiration time, maybe 15 minutes, maybe a day. You know how your banking app logs you out after a while? Same idea. A secure token also never contains secrets in its payload, and it's stored where scripts can't steal it. An insecure token, on the other hand, might last forever or have your password inside, basically leaving the front door to your account wide open. So let's just quickly recap the golden rules here. 1. Always give your tokens an expiration date. This limits the amount of time an attacker has if they do manage to steal one. 2. Never ever put sensitive data in the payload. Assume it can be read. 3. Use HTTP-only cookies. This is a huge defense against someone trying to impersonate you. And 4. Guard that secret signing key on your server with your life. If that key leaks, all of your tokens are compromised. When you put it all together,
This combination of middleware and JWTs creates this beautifully efficient and secure system. Every request becomes a quick, secure handshake. And maybe the best part is that the server doesn't have to keep a big list of who's logged in. It's stateless. All it does is check your key, which is a very, very fast operation.
And that kind of leaves us with a final thought to chew on. We just broke down one type of digital key for one website. But as our entire world gets more and more digital, what are the keys of the future going to look like? What will be the keys to our cars, our homes, our very digital identities? It's a fascinating thing to think about.